So welcome back to BioMindscape. Today we are going to know about the respiratory volume and capacity. So first is the tidal volume. The tidal volume is a volume of air inspired and expired during a normal respiration. That is approximately 500 milliliter. That is a healthy man can inspire, that means inhale and exhale approximately 6,000 to 8,000 ml of air per minute. Then IRV, what is IRV? Inspiratory reserve volume. A person can inspire by a forcible inspiration, that is average to 2500 ml to 3000 ml. Expiratory reserve volume ERV, that is a person can expire by a forcible expiration, that is average 1000 ml to 1100 ml. Here residual volume is volume of air that is remaining in the lungs even after the forcible expiration. The average, that is 1100 ml to 1200 ml. By adding up a few respiratory volume described above, one can derive various pulmonary capacities which can be used in clinical diagnosis. Then inspiratory capacity is the total volume of air a person can inspire after a normal expiration, and this include the tidal volume and inspiratory volume, that is TV plus IR, that is IC. IC is equal to TV plus IRV. Whereas expiratory capacity is the total volume of the air a person can expire after a normal inspiration, and this include the tidal volume and expiratory reservoir volume, that is TV plus ERV. Always remember IC is equal to TV plus IRV. Here IC is equal to TV plus IRV, whereas EC is equal to TV plus ERV. Only we have to remember this wherever there is EC, then it will be TV. We have to add the TV with ERV for the EC for expiratory, and wherever there is inspiratory capacity, it is TV plus IRV. Then the vital capacity is the maximum volume of air a person can breathe in after a forcible expiration. So this include ERV plus TV plus IRV, or the maximum volume of air a person can breathe out after a forcible inspiration. So here the total lung capacity. The next is the TLC, that is total lung capacity, where the total volume of air accommodated in the lungs at the end of a forcible inspiration, and this include the RV, ERV, TV and IRV, or the vital capacity plus residual volume. So these all are the important respiratory volumes and capacities. So here we can see a table that show the tidal volume, inspirational volume, inspiratory volume, expiratory volume, residual volume, inspiratory capacity, and their definitions and their formulas as well as their values. So MCQs can be asked like tidal volume, what is the value of the tidal volume, that is 500 ml. Inspiratory reserve volume, that have a value of 3000 ml. Then expiratory volume, that have a volume of 1100 ml, and residual volume, that have an volume value of 1200 ml. Whereas inspiratory capacity, it have an value of 3500 ml, and expiratory capacity, it have a volume of 1600 ml. So these you must be thorough with. And inspiratory capacity, it have a formula, that is TV plus IRV, and expiratory capacity, the capacity, it have a formula of TV plus ERV. Whereas the vital capacity, it have a formula of TV plus IRV plus ERV. Both we have to add. For the vital capacity is the total of all the values. Then total lung capacity, that is VC plus RV, that is total lung capacity, that is 5800 ml. Let's solve an MCQ. Here we have given a match the pair is given here, where the column is shown the tidal volume, inspiratory reserve volume, expiratory reserve volume and residual volume, and the values are given for them. For example, the tidal volume, how many what is the value of tidal ml? We know that it is 500 ml. So we have to see the option that is showing 500 ml. So here A is 3. We can see in both option A and B. Now other options, they are eliminated. Now let's see, for A is 3, and let's see the inspiratory reserve volume, what is the value. Is it 11 to 12, or is it 2500 to 3000 ml? So we know that inspiratory reserve volume is 2530. It is a short form. I have made a mnemonic for this to remember the values. For example, for tidal volume 500, for inspirated reserve volume 2530. 2530 is inspirated reserve volume. Then expirated reserve volume, that is 1011. 1011 is expirated reserve volume. And for D, that is residual volume, that is 1112. 1011, that is this one, expiratory reserve volume. Expiratory 1011, inspiratory 2530, and residual volume, that comes out to be the 1112. So here the correct option is option 2. So here a healthy man can inspire or expire approximately how much air per minute during normal breathing, that is 6000 to 8000 ml. So the tidal volume, that is approximately 500 ml, we know that. And in NCERT it was given a line that a healthy person that breathe 12 to 16 times per minute, and the total volume per minute, that is 500 into 12 to 500 into 16, which comes out to be 6000 to 8000 ml. So now you know that how this 6000 and 8000 came. Here we can see a question: which of the following respiratory volume cannot be measured directly using a simple spirometer? That is residual volume. Why? Because residual volume in the air that remain in the lung even after forced expiration, because it never leave the lung, and spirometer, it cannot capture it. Why it is not tidal volume or ERV or IC? Because tidal volume, that TV can be easily measured as it represents normal breathing in the air and movement, whereas expiratory reserve volume can be measured by having exhale as much as possible after the breathing, whereas inspiratory capacity, we know that it have a formula, that is TV plus IRV, where both of which are measurable by the spirometer. Inspiratory capacity is measured by the spirometer. Next question was, what is the correct formula for calculating the vital capacity, that is TV plus IRV plus ERV. Vital capacity is maximum volume of the air a person can breathe and in after a forced expiration or breathing out of and forced inspiration. A functional residual capacity of represent the volume of the air that remain in the lungs after forced expiration. Why is it false? False because FRC is a sum of ERP plus RV that represent air left after a normal quiet breathing. Next question is the additional volume of the air a person can inspire by forceful inspiration, and it is called as IRV. Why it is? What's its average value? That is 5 to 2530. We know that IRV, we have made a mnemonic for it for understanding, that is 2530 for the IRV. So the correct option for this is 2500 to, that is 3000 ml. IRV is significantly larger than ERV, that is averaging between 2.5 to 3 liters in a healthy. Here we can see a question which is showing that total lung capacity TLC can be mathematically expressed as VC plus RV. What is this? TLC is total volume of air that is accommodated in the lungs at the end of the forced inspiration. Since VC, that is this volume, total volume, that is TLC, and the vital capacity, that is movable, and the reservatory volume is the remainder, that is the remainder, that sum is TLC. The total sum of the total volume is VC plus RV. During a forceful expiration, the volume of the air exhaled after a normal tidal expiration, that is expiratory reserve volume, because forceful expiration, this word when it comes, and the volume of the air exhale after a normal tidal expiration, that is the expiratory reserve volume. Expiratory reserve volume is addition volume, adding the volume of the air a person can expire. That means we inhale and exhale. So exhaling forcefully beyond a normal tidal breath, that is expiratory reserve volume. Here we can see the oxygen dissociation curve. It represents the relationship between the partial pressure of oxygen PO2 and the percentage saturated of the hemoglobin with the oxygen. So it has a sigmoid S shape that is formed due to cooperative binding, where the binding of one molecule of oxygen increases the affinity of hemoglobin for the next. So in the lungs, that is partial oxygen that is high around 100 mmHg, hemoglobin become almost fully saturated and ensure efficient oxygen loading. In contrast, in the tissue where the partial oxygen is low, that is 40 mmHg, the hemoglobin release oxygen providing it for a cellular activity. Factors such as increasing carbon dioxide, increasing hydrogen ion concentration, lowering the pH and higher temperature shift the curve to the right, that is Bohr's effect, and decrease the hemoglobin affinity for oxygen and promoting its release in the actively respiring tissues, and this property make hemoglobin highly efficient in transporting oxygen, delivering precisely where it is needed. For knowing such concept, follow BioMindscape.